My name is Mylon Thompson-Bukovic, and I'm a Vice President of Technology at AWS. Now, I have been working on AWS cloud services for over 13 years now, and I focus on those large-scale data services that are central for any cloud application, like storage, streaming, messaging, and observability. Now, every modern business is a data business, and I have spent a lot of time over the years talking to customers about how to use data to drive their digital transformations in the cloud. Now, we are having that same conversation about how to use your own data with generative AI. Generative AI, as many of you know, is a kind of AI that creates new content, whether that is imagery or text or audio or video, and it's based on the patterns and data learned by the underlying model. Now, that generative capability, as you all know, can transform how businesses think and operate, but to do that, you need to understand the role of your own data in generative AI. And that's what we're talking about today. How to customize your generative AI applications and your IA system with your own business data. We're also going to unpack the top 3 data initiatives that are central to generative AI that span industries and geographies. Now, if you are somebody who works with data in an organization and you aren't talking about these 3 initiatives, you'll want to start. They are just so critical for businesses that are adapting generative AI. And as part of this conversation today, I'm going to help you connect the dots between these 3 critical data initiatives and the most important announcements for data this week. My goal is not only to share what data organizations across the world are doing for generative AI, but also how you can use AWS to put your data to work. Now, data is growing at an incredible rate, and it's powered by consumer activity, sensors, business analytics, and so many other drivers. That data growth is driving a flywheel for generative AI. Foundation models, or FMs, are trained on massive data sets from sources like Common Crawl, which is an open repository of data that contains petabytes of web page data from the internet. Now, enterprises, companies like yourself, are using smaller private enterprise data sets for additional customization of FM responses and creating what's really a new intermediate set of data. I'll talk about that more today. These customized models will in turn drive more generative AI applications, which through customer interaction create even more data for this data flywheel. So what data is going into that flywheel? IDC forecasts the amount of data generation on an annual basis, and they predict that the growth of data over the next 5 years is going to be 22%. Now, that data is going to include structured and unstructured data, but the vast majority of that is going to be unstructured data, like video and PDF files, audio, text files. 90% of that data is going to be unstructured, and it dominates the growth of data in the upcoming years. Now, the quality of that data matters for generative AI because higher quality data improves the accuracy and the reliability of the model response. In a recent survey with CDOs, we found that almost half, 46% of the CDOs, view data quality as one of their top challenges to implementing customized generative AI, and 93% of those CDOs said that the importance of the end-to-end data strategy and its role in making generative AI custom to their business is one of the most important things that they can do. So it's not just data that matters. It's high-quality enterprise data that is safely and correctly and responsibly used. So let's start by understanding the relationship of data all up with FMs. Now, as many of you already know, FMs are large neural networks trained on massive data sets to develop a broad or generalized understanding. And these capabilities can then be customized for specific tasks. Now, because these models are trained on vast amounts of data, they are able to learn more complex representations and patterns. And many of the leading FMs are trained on data stored in Amazon S3. Like the most recent Falcon 180 billion parameter model is trained using data in S3. And Anthropic uses S3 to store hundreds of petabytes of training data and model parameters. And because those FMs are trained on multimodal data, for example, both text and images, they understand different modalities, which in turn enriches their generalized understanding of tasks. These are the FMs that are driving a new generation of applications. So one of the questions I hear from customers all the time is, should I use an existing FM or train a new model? And the vast majority of the time, my answer will be, use an existing FM, because these models are just so capable and they're evolving so rapidly in their generalized understanding and knowledge. Plus, you can customize the responses of these models or the models themselves with your own enterprise data. And that process got even easier this week. And that's what I'm going to be talking about in a little bit. Now, folks, this is a place where some of you who are already deeply knowledgeable in ML AI, and I'm going to be telling you a few things that you already know. But we have others in our audience who are learning. So I'm going to give a super quick summary of some ways to customize generative AI experiences. And for those of you who already know how FMs work, we're going to be digging in shortly with details about how customers at scale, like Adobe and Pinterest, are doing generative AI with their custom data and how AWS is helping. So hang tight. Let's talk about those 3 techniques for customizing an FM with your own data. And I'm going to start with the easiest first. Many customers use prompt engineering to customize their foundation model. And that's because it's both simple and it's cost effective. And it lets you refine your inputs or your prompts for generative AI so that you get on-target outputs and optimal results. Now, you can customize the outputs of an existing model using a technique called Retrieval Augmented Generation, RAG, and you don't need to retrain your model if you're using RAG. That's really important. With RAG, external data is used to augment your prompts, and they can come from multiple data sources, including document repositories, APIs, databases, and RAG helps the model adjust the output with data retrieved as needed from these knowledge sources. Now, when you fine-tune an existing AM, you're using a smaller data set from your own domain, and it's basically creating a new model for you with your prep data set. The same thing if you're doing continuous pre-training. If you do continuous pre-training, which you can do with some FMs, you're picking up where the FM provider left off. You're training the model on data sets in your enterprise to extend both the generalized and specialized knowledge of the model. Now, I'm going to walk through these 3 different techniques in the context of Amazon Bedrock. And that's because I think the easiest way and best way to evaluate which technique is right for you and which model you want to use is using Amazon Bedrock. If you haven't tried it yet, you should. I think Amazon Bedrock is amazing. It has a lot of capabilities today. It's evolving at a super rapid rate. And as of this week, it supports all 3 of these capabilities to customize your model responses with your data. So let's talk about each of these in more detail, but we're going to talk about them from the context of the data characteristic. If you have data that changes often, like weather data, product inventory, or news, you aren't going to want to update your model every single time your data changes, which would be super often if you're passing in recent weather patterns. For fast-changing data, we find most of our customers tend to use RAG. RAG helps your model respond with the most recent data as context, and it influences the response so you're not changing the model itself. Instead, what RAG does is it adds data into the context of the user's request or question to bias the model's response in the right way. Say, for example, you want to train your FM to learn last week's sales reports. A RAG-based system can incorporate that data in the FM's response. Now, RAG works by retrieving relevant facts from an external knowledge source, like a file in S3, and it grounds the FM on the most accurate and up-to-date information. Now, with RAG, you preload the information that's based on your own data into the context of the LLM by taking your data and creating embeddings for it. Now, embeddings are numerical representations of your text, image, or video, or audio, but it includes the semantic meaning. It creates a semantic meaning that is basically stored in a really fancy index at the end of the day. And that semantic awareness can mean the difference between a model knowing if you're talking about a financial table or a dinner table, or if when you use the word bike, you're talking about a motorcycle or a bicycle. And as of this week, we also have Claude 2.1 model available in Bedrock. And what's super interesting about the Claude 2.1 model is that it has a 200,000 token window. That is super helpful for RAG because it means you can pass in as much as a 500-page document as a prompt. Now, RAG is the easiest way to customize model responses with your own data, but customers can also do fine-tuning as well. Now, fine-tuning an existing FM means that you're training the existing, or you're customizing the existing FM on your domain-specific data, and that is giving it context on your underlying enterprise. Now, what's interesting about fine-tuning is that you can not only specialize the model to your domain, to your context, but you can specialize it to your tone or your style through that sample data set. So when you're fine-tuning, you're providing examples that not only set the domain context, but also the style that you want to inject in your customized model. Now, this takes a little bit of data prep to get to that high-quality, curated data set, but it can really impact the relevance of the responses for the model. Now, keep in mind, models are only as good as the data that they learn from. So make sure you're using high-quality data when you're fine-tuning. And as of this week, fine-tuning in Bedrock is generally available for Cohere Command, Metalama 2, Amazon Titan Text, Amazon Titan Multimodal Embeddings, Amazon Titan Image Generator in preview, and fine-tuning support for Anthropic Claude is coming soon. You have a lot of choice for fine-tuning for customization. Now, the third way that you can customize a model is to do continuous or continued pre-training. In this way, you're picking up where the FM provider left off, and you're using larger, unstructured, and unlabeled data sets stored in your enterprise, like thousands of text documents in your data lake for S3. And today, Bedrock supports pre-training with Amazon Titan models. Many of our customers, by the way, are going to be using multiple techniques with multiple FMs, as in they're going to be using FMs as is, they're going to be fine-tuning, they're going to add RAG with context, and sometimes they're going to do pre-training, continued pre-training of a model. We see customers at scale often have a collection or really an ensemble of models that drive their AI system. And I can't think of a better person to talk about how to use generative AI at scale than Alexandru Costin, the VP of Adobe Firefly and Sensei, which are the products powering generative AI in Adobe products for thousands of creators today. Please join me in welcoming Alexandru.
Thank you, Mylan. Happy to be here, everybody. My name is Alexandru Costin. I drive the generative agenda at Adobe, and I'm here to talk about how we use some of the AWS capabilities, how do we think about our data to teach some of the learnings we had in our journey. And at Adobe, we've been serving our customers for 4 decades, and we've helped them navigate many technological disruptions, digital photography, internet, social era. But last year, we realized that a new era was happening, the AI era. And for us, it was a very important moment, and we've decided to invest early and start doubling down on re-transforming the Adobe product lines into AI-enabled products. And we talked to many customers across all our segments. We talked to consumers, we talked to small businesses and students and education. We talked to our creative professional users, and we talked to enterprises, and we asked them, what do you think Adobe should do in terms of bringing generative AI to all of you the right way? And they told us they need particular things because they're very specific about creating and editing content. They told us they want control. They want to be able to make sure they can materialize what's in their mind's eye and be able to create and tell the story they want to tell. They told us integration in our product line is very important. And for that, we want to bring those capabilities inside the products they live and use, like Photoshop. They also told us that they want to customize it, be able to create content on brand and create content variations at scales. But most importantly, they told us they need us to create content that is safe for commercial use. Meaning they gave us this strong signal that we need to think really deeply about the data we use to train our models. And this is what helped us create a series of models this year and across image generation, vector generation for illustrations, and design generation. And I'm going to show you a quick video with some of the capabilities we've launched throughout 2023. Thank you. We're very proud of what we've accomplished, but we're here to talk about data. Before doing that, though, very important for us was the success those capabilities had with our customers. Seeing that we trained on the right data, we gave them the capabilities they needed, led to amazing success and use of those capabilities. Like, for example, Generative Fill, which is how the Firefly model is integrated in Photoshop, is the most used feature in Photoshop today, is used at a rate of 10x more than any other feature we've introduced ever in the Photoshop history. And throughout the year, more than 4 billion images have been generated with Firefly. And again, a very important point for our customers was how we trained these models, the data we trained on. And let me walk you through how we do it. And reiterating also what Mylan said, when we talked about data, we have the Adobe Stock Marketplace. We have a marketplace of content, hundreds of millions of images, illustrations, videos that Adobe is offering to our customers, and where we have stock contributors that participate in this marketplace. And we've decided to take this as the foundational data set we want to train our assets on. And of course, the stock images are stored in AWS. But we've also decided to enrich this data with a lot of embeddings and augmentations to make this data better for training these models and increase their quality. And there are a lot of models involved in this process, models that make the data better for training and also models that participate in the generation. When we think about the whole process on how we train our models, so we have the Adobe stock, hundreds of millions of assets. Those assets are already curated and moderated, both using human moderators and AI, to not contain trademarks, intellectual properties, or recognizable characters. Because we want to make sure our model cannot generate those, so our data is filtered. And this ensures us, gives us the confidence that our model cannot generate a particular brand or logo or recognizable character. We take all this data, and then using various LLMs and other classifiers, we augment it. We create these pre-computed embeddings that help us not only add quality to the data, but in the same time increase the speed at which we train, because having these pre-computed embeddings allows us to train faster, not having to recompute it every time. We do large distributed trainings, and we load the data. It's a very important part of the equation to load data fast, keep the GPUs occupied. So we keep data in S3, we keep data in the LaSTAR-FX and in FSX, and we continuously monitor it for, continuously synchronize it with the database in Adobe Stock, and check for lineage and make sure that we have traceability of how models are trained, which data was trained. To make models better, we also have this process called RLHF, you might have heard of, reinforcement learning with human feedback. So we collect likes, dislikes, downloads from our apps and feed those back into the training data to teach the model to generate more assets our customers would love. So at the macro level, when we decided to go about it, and again, this was 2022 for us, we created a team responsible for creating data sets as a product. This data team has the sole role of taking data, preparing it for training, compacting it in a diverse way, computing these embeddings, and sharing it with hundreds of Adobe researchers and Apply researchers so they can focus on training the models, making sure that the data they train on is very high quality. We operated with petabytes of data, petabytes of raw data, petabytes of embedding. When we fine-tune for a new modality like illustrations, we add more petabytes, and vectors and videos are going to increase the quantity of data we have to operate on. And using AWS scalable solutions enabled us to move very fast and not worry about any of those data sizes. Those were data sizes the Amazon solutions helped us operate at. But we've built software on top. We used open source to stream our data to these training machines. So we package the data, we store it in S3. We're very excited about the S3 Express One Zone, which will allow us to keep the data closer, faster to the training nodes, and also cheaper. And we compact those data into shards, and we stream that to the training machine. So very important with multimodality to invest in a software layer or use some of the offerings AWS is bringing to the table to make sure your GPUs stay occupied all the time during training. And for us at Adobe, while we decided to train our own FMs, so we're a large company, we think our customers need us to invest in our own FMs, we've also tried to stay ahead of the regulations. We always did responsible AI. We've invested in something called content authenticity that enabled us to bring to the table transparency in how not only we train the data, but transparency in how documents are AI generated or not. We're working with different governments and giving them advice on how to improve and regulate training to make sure that everybody in the world and governments can have a say in how models are created to make sure they're trained responsibly. And we also invest in heterogeneous computing because this is a challenge we're seeing these days where not only you need to train on your data, but sometimes you need to add some of your customers' data to create better products. I was very excited to see the announcement of the Amazon Clean Room that might give some of that opportunity to bring data sets together in a clean way without interference. And if you train with data on the internet, there are emerging threats, things like the laws changing, but also data poisoning. There are new techniques that are happening out there where artists are trying to protect their data by labeling it in a novel way. So you need to really invest in how you collect, manage, and govern your data sets to make sure your models, being them ragged or fine-tuned, are high quality. Finally, again, I hope our story helped you understand how we succeeded at Adobe to create many models, and we have many more in the pipeline by really investing in data. We think it's still an exponential, we're living exponential time, so it might feel late for some of you to come in, but I think the biggest change is still ahead of us in terms of how those generative models will change industries and hopefully will make all the knowledge workers' businesses better. We do think more data transparency and governance will be needed, and regulations will enforce that in various geographies. And I do hope that you will also take this to heart and start investing in your own data sets, start training and fine-tuning your models in order to succeed and embrace this generative AI wave. I want to thank again the AWS team for the partnership. We wouldn't have been able to succeed without them. And I think Milan will join me on stage in a second. Thank you.
Alexandru, thank you so much for
You're
sharing
welcome.
your story at Adobe. Pretty amazing, right? Thank you, Alexandru. What Adobe is doing to transform the creative world is going to have an impact for decades to come. And I think you got a sense of how they're doing it at scale. Now, I talk with a lot of customers about data. And what I wanted to do today is to share with you the top 3 data initiatives that are central to generative AI, regardless of your industry, your use case, or your geography. Here they are. The first one is to use your custom data to differentiate your AI system. The second is to make your existing data architecture work with generative AI. And the third one is to become your own best auditor now for generative AI applications. And if you think back to what Alexandru talked about, Adobe is doing all of those. So the first one I'm going to start with is using custom data to differentiate. Now, if you are training an FM, you are often using vast amounts of data. But if you're customizing your use of FMs through RAG, fine-tuning, or continued pre-training, you're using far smaller data sets, and ones that set both the specialized content as well as the tone or style. And that means picking the right data sets from your corpus of enterprise data and prepping it to make sure that you have the highest quality. This is the first challenge for data practitioners like yourself moving to generative AI. Most businesses have a lot of data. And for RAG, it has to be the most relevant data. For fine-tuning, it has to be the right data examples, labeled and prepped in the right way. And for continued pre-training, it has to be a largish, high-quality, unstructured data set. Now, in the traditional ML AI world, data scientists do the data prep. But in a growing number of cases, we're seeing customers use LLMs and tools like SageMaker, Amazon SageMaker, to do the data classification, the data labeling, and other data preparation tasks. Often, there is still a human in the loop, validating the data. But that heavy lifting of the data prep is done by the LLM itself or a managed AWS tooling like SageMaker. Now, once you have those high-quality data sets that you want to use for your customization of your AI system, you have lots of choice on your next step of connecting the data up with your model. The easiest way is, well, it's to connect up your data. And you can do that with an AWS AI application like Amazon Q. With Amazon Q, which we announced in preview this week, you have 43 native connectors to your data. There is no easier way to get going with a generative AI application than Amazon Q, because you can just point it at your data behind your data perimeter and get started. Bedrock also makes it amazingly easy to connect up with a variety of enterprise data sources. A few months ago, we previewed a RAG capability in Bedrock called knowledge bases. And what knowledge bases do is they securely connect your FM with proprietary data sources, like your documentation in S3, to supplement your prompts with more information so your applications can deliver more relevant, contextual, and accurate responses. And as of this week, Amazon Bedrock Knowledge Bases is now generally available with an API, a single API that performs the entire RAG workflow from fetching the data, for example, the text needed to augment a prompt, to sending the prompt to the FM, to returning the response. That makes it incredibly easy to connect up with Amazon S3, APIs, databases, you name it. Now, because at AWS, we know developers want choice, Knowledge Bases supports different vector engines, including Amazon OpenSearch Serverless, Amazon Aurora, which is coming soon, ones from Pinecone, Redis Enterprise Cloud, and MongoDB coming soon as well. Now, if you're a data scientist or an analyst, another great option for leveraging FMs for business analysis is SageMaker Canvas. Canvas provides point-and-click tools with low-code extensions for data scientists and business analysts so that they can work with data sets used by foundation models that power all those generative AI applications. Here's the thing with Canvas. You don't have to be an expert ML practitioner. All you need to know is your data. And earlier this year, customers were able to use Canvas to access multiple FMs on Amazon Bedrock or through SageMaker Jumpstart. And now with Canvas's no-code interface, customers can upload a data set, select an FM, and Canvas automatically starts helping customers build their custom models. All right, we've talked about how you can create and use custom data sets. The second data initiative that every data practitioner needs to think about is leveraging and extending your existing data architecture with new generative AI applications. Here's a fact. Customers do not want to create new data architectures for what is essentially a new application type. They want to take advantage of the existing systems that already exist to store and use data for other business applications. And they want their generative AI applications to follow the rules of the enterprise for data access, governance, and compliance. Think of those generative AI applications as a new application type that sits on top of an existing data foundation. That means you want to plug in your existing data sources, like your S3 data lakes, and you want to use other data building blocks that you and your organization are already familiar with and using today in your data architecture. So I talked earlier about how important it is to keep the vector data up to date with the most recent data, because that's how you get fast, accurate, and relevant responses using RAG. Now, with AWS, customers want to use their data store to store embeddings too. They can use Amazon OpenSearch, which is a great choice if your use case involves search. And that's because it provides you semantic search. It combines the vector and full-text search in a single query. If you're using Amazon Aurora PostgreSQL or RDS PostgreSQL, you can use a PG vector extension as your vector store. They're a great choice if you're already using those relational databases and you want to join the vector data with the traditional table data in your queries. Another option is Amazon Kendra, which is an end-to-end managed service that automates the entire process of ingestion connectors from over 20 source systems to the generation of the vector embeddings. And just a couple days ago, we introduced vector capabilities in Amazon Neptune, our managed graph database service, as well as vector support for Amazon Memory DB, which is our in-memory, Redis-compatible, fully durable data store. If you want another vector database provider, like Pinecone, you can select a choice you want directly from Amazon Bedrock. Our goal here is to provide you choice, so you can use your preferred technology, the one where you already have your skills in your organization, and just extend it to include vector as part of your new AI system. Now, when you build on your existing architecture, you can also leverage and extend those data pipelines that are already in place today. Now, many of our customers use AWS streaming technologies like MSK, Managed Apache Flink, and Amazon Kinesis to do real-time data prep in traditional ML AI. You can take those workflows and you can extend them to capture changes to your data and make them so that you can make changes to your data available in real-time updates to your vector store. You can update the fine-tuning of your data sets with integrated data streaming in S3 using Amazon Firehose. And you can do other changes to extend those existing workflows and make them work with your new AI system. Basically, if your data infrastructure is already built using AWS services, you are already most of the way there to just extending that to work with generative AI. Along with managed services like Amazon Bedrock, which is purpose-built for generative AI, we continue to add new capabilities into all of our services so that your existing data architectures bridge easily into generative AI applications. Now, sometimes that means taking generative AI capabilities and putting it into our AWS data services, so that helps you manage your existing data architectures better. For example, Amazon Data Zone this week announced support for automated descriptions using generative AI, which is an LLM-driven capability, so you can easily enrich your business catalog by automatically creating comprehensive business data descriptions and context for those business sets, or those data sets. In other cases, what it means to bridge generative AI from your existing architectures includes new features like Glue, which introduced the ability through Glue Data Insights to simplify how you improve the quality of your data sets used for training and inference. So data quality insights automatically detects anomalies in your data set by analyzing data statistics using ML algorithms, telling you about hidden data quality issues and unusual data patterns. Now, here's another example of how we extend your capabilities on existing services. We have a lot of customers that use Kubernetes for ML training and inference. And the health of those virtual machines is critical to completing a generative AI workflow. And so earlier this month, we announced at KubeCon CloudWatch Enhanced Container Insights for monitoring EKS clusters. Now, these metrics are going to help any EKS user, but they're actually super helpful if you're doing generative AI workflows like fine-tuning. Key metrics like GPU utilization are included by default, but you also have access to other incredibly useful metrics like power draw, container CPU, or encoder latency. These metrics are aggregated by cluster, namespace, job, or pod, so you can monitor and maximize the uptime for your EKS-hosted workflow. And if you look across your data architecture, you are going to see places all over your data strategy and architecture where the fast pace of AWS innovation helps builders of generative AI applications. Let's take Amazon S3. Amazon S3 has well over 700,000 data lakes today, and we have customers that have terabytes or exabytes of data. Amazon S3 begins where the internet ends when it comes to specializing FMs for your enterprise. Here's why. The data in S3 is inherently high quality. And that is because it's already being used for business operations, like analytics and fraud detection. That data is already at work in your enterprise. And so it is a very short step to take that high-quality data you have in your data lake and use it to customize your AI system. When you are using enterprise data in S3, you are typically working with already a great source of high-quality data for generative AI. And when we extend Amazon S3 capabilities, as we are always doing, generative AI practitioners get the benefit of that, as well as developers of any application type. Here's a specific example. Earlier this week, S3 announced S3 Access Grants. Now, data lake customers are super excited about this because it gives you the ability to apply fine-grained controls all the way down to the prefix level of S3. But that also helps generative AI developers who are using shared data sets for RAG, fine-tuning, and continued pre-training, because it lets you maintain strict and logged access controls over those shared data sets, and it even offers integration with third-party identity providers. So again, everything we're building into our AWS building block services like Amazon S3, they're going to help any application developer, but we have the capability of also extending those into the generative AI workflows. This fine-grained control I talked about, it really matters for AI systems because you're often working with shared data sets. For example, you might want to use that same prepped data set for fine-tuning different models, or you might want to have one set of critical documents that you use for different RAG in-context learning. And with access controls, as of this week, it's a fully auditable way to provide specific access, like time-based permissions or read-only permissions, right down to individual prefixes. So if you think about that, you think about that concept of the shared data set that's already at use in data lakes today for business analytics, fraud detection, personalized advertising, you name it, that's also going to apply to generative AI applications. Well, speaking of data lakes, Pinterest was one of the first to adopt a data lake architecture many years ago, and they have already deployed generative AI at scale for use with their data lake. So I am delighted to invite Dave Burgess, who is the VP of Data Engineering for Pinterest, to come and share with you how Pinterest puts their data to work for generative AI today. Dave? Welcome.
Thanks so much, Mylan.
Yep.
Thank you. Good afternoon, everyone. I'm Dave Burgess, VP of Data Engineering at Pinterest. I'm going to talk about extending our existing data lake with generative AI. So Pinterest is the visual inspiration platform where people come to search, save, and shop the best ideas in the world. We have 482 million monthly active users around the world and 1.5 billion pins, these are images, that are saved every week. We've created a really agile engineering culture on AWS's cloud where we can rapidly develop and deploy software in production at scale. We've been in AWS's cloud for 13 years since we were born. We run thousands of experiments in parallel to win or learn. We can train and deploy ML models into production within a day. And we have dozens of ML use cases that together execute hundreds of millions of ML inferences per second. This generates upwards of 80 million events per second, which we log, process, glean insights from, and do ML training on. This has resulted in us storing an exabyte of data in our data lake, and Pinterest is one of the largest data lakes on Amazon S3 on the planet. So Pinterest is a mix of AWS technology and open source software. Our data consumers range from engineers and data scientists to product managers and executives. We really have a data-driven culture, a data-driven business. All these users create queries in Pinterest's open-sourced query book and superset analytics user interfaces. We execute these queries via Trino and Spark open-source big data engines that run on Amazon EKS. We have tiered our data based on the schema design and the quality of the data and the documentation. And we store all of our metadata, such as our schemas, fields, metrics, definitions, in Data Hub, which is an open source data catalog. The goal of our highest tier 1 data sets is to enable 80% of our company's queries to be executed. And even with these capabilities and the infrastructure, we felt that we could improve our analytics productivity even further using generative AI. So, first, we identified our analytics productivity pain points. So what I'm about to describe is how we significantly improved our analytics productivity using large language models and RAG with our existing data lake. On any given day, our users and business intelligence team have many, many different analytics questions that they need to answer. And they're constantly working on trying to figure out the answer to these questions. These questions range from knowing what data to use and how the fields and metrics are defined, to what the quality of that data is, where did it come from, is it trustworthy, and how to write the queries in SQL. We saw an opportunity here to solve these pain points by using RAG. And the main way that we did this was to automatically generate the SQL queries from text questions. We found that the text-to-SQL generation is about 97% accurate, given the right table to use. However, we do need to find that right table, that right tier 1 table to use in the SQL query. And for this, we needed to have text descriptions of our tables. So we used large language models to actually generate the text descriptions of our tables from the table schemas as well. Here's a demo of Text-to-SQL in QueryBook, which runs in production and has been open sourced, so you can use it if you like. You type in a question in the QueryBook, and QueryBook generates the SQL and executes it for you. You can also edit the SQL, and QueryBook will verify the syntax is correct. And if you would like, you can automatically generate a title for your query as well, if you want a little bit of panache. So here's a glimpse of our generative AI elements, which we added to our data lake for text-to-SQL, and this was built on top of AWS. This was done by 2 engineers, very, very capable engineers, in a matter of a couple of months, working part-time on this as a side project. So it really is quite easy to go and set this up. When the user asks a question, we first need to find the data tables to use using AWS OpenSearch. This is a distributed search and vector engine. And OpenSearch has the table schemas in them, the description, the tier of the table, and example queries to recommend the best tables to use. And then once we have the right tables to use, we can then create a prompt for the large language model and generate the SQL via the large language model. Okay, so what was the impact of this? So by being able to automatically generate SQL from text, this has resulted in 40% gain in productivity for our product analysts, our data scientists, our product managers, and our engineers. And most of this is from speeding up the data discovery part and the data creation time, finding the right table to use automatically, and creating and executing the SQL. So we've used off-the-shelf large language models for this use case. Some of the latest ones give excellent results with 97% accuracy. And we've also used these large language models for other internal developer productivity use cases too. We find most of the differentiation is in the prompts and the data that we've fed into these large language models. And we've got an example here of a prompt that you can use, if you'd like, by going to this URL to actually generate the SQL from the prompt. I'd like to thank the Pinterest engineering team, Pinterest as a whole, and also Meilan and team for really close partnership with AWS. Thank you.
Thank you, Dave. Great job. Pretty amazing, huh? 40% productivity gain from that. They have an amazing data lake. They talked about an exabyte of data. But they also talked about how generative AI is at use at scale in their engineering workforce to make sense of all that data. And part of the reason why Dave and Pinterest were able to move so quickly to generative AI is because they were starting from their existing data architecture that was based on Amazon S3 for their data storage. And from there, it was just a short step to integrating LLMs into their existing system. It's just one of many examples of how companies can put in place AI systems very quickly when they're starting from AWS services. And that is because AWS is constantly innovating for what customers want. And I wanted to give you some examples of that for new releases that happened this week that are really going to matter for generative AI practitioners. Here's one example. The data path between compute and storage is incredibly important for generative AI workflows. Speed matters on that data path, and it matters because it speeds up the model training and the inference process. So, as an example, for us to accelerate training workflows, we went into many different parts of that data path between compute and storage. For example, we've significantly sped up the default command line performance for data retrieval from S3 from very commonly used instance types for generative AI applications like Trainium1, P4D, and P5 instances. And because we know so many customers are using EKS to orchestrate their distributed training jobs, as of this week, we introduced a new CSI driver for S3, so you can natively provision and mount S3 buckets to access S3 objects through a file system interface directly from Kubernetes. If you are using Kubernetes on EC2 or EKS, you should use this. You get high aggregate throughput without having any changes to your application code. That's new this week. We're also optimizing the performance for commonly used frameworks in ML AI workflows. We know that customers use Python for ML AI training, so we accelerated the performance of the AWS Python SDK for S3 access, and that automatically incorporates optimizations like automated timeouts, retries, request parallelization, and again, customers don't have to write a single line of code. These optimizations are just going to speed up your ML AI workflows like data loading and checkpointing. We've also just added file cache for S3's open source client-side Fuse connector. We call it Mount Point for Amazon S3. And that file cache, that's going to speed up all your multi-epoch training jobs to reduce the cost of repeated access to that data. And just last week, we introduced a new Amazon S3 connector for PyTorch open source project for the PyTorch open source framework. Now, for those of you who are doing ML today, you know that PyTorch is an incredibly popular machine learning framework to build and train machine learning models. And now you can use the Amazon S3 connector for PyTorch to automatically optimize your data loading and checkpoint performance for your ML training workloads. And as Adam said during the keynote, S3 this week launched a single zone high performance storage class called S3 Express One Zone. It gives you the highest performance and lowest latency cloud object storage with consistent single-digit millisecond latency. And Express lets you scale to millions of access requests per minute. Millions. And with request costs that are 50% less than Amazon standard, you can reduce your total workload costs across compute and storage by up to 60% compared to Amazon S3, because your jobs are just going to run faster. Now, Express One Zone is much, much faster than any other storage class in S3. S3 standard was the fastest storage class, but now Express One Zone is 10 times faster than standard. All of these examples that I just gave you are just a few different examples of the innovation throughput that we have across our AWS services that help the generative AI builders on AWS. Now, I am now to the third data initiative that data organizations in every industry and every geography are paying attention to. And I believe that every data organization needs to be their own best auditor now for generative AI. Customers should know what data sets you're using for training, customization, fine-tuning, RAG, and you need to know how the model's making decisions. In a rapidly moving space like generative AI, you need to look around the corner and become your own best auditor. And every organization has to prepare for a world of regulation and compliance. We know it's coming. We know it's going to be different in different countries. And in order to be prepared for that, you need to do your own auditing today, and you need to do it in a fully automated way, because that is the only way you're going to be able to scale to the use of generative AI. Now, today, you store, protect, and govern your enterprise data sets. There are new data sets in town for generative AI. And it's everything from the prep data set for fine-tuning to embeddings to the generated data you create. And so when I talk about being your own best auditor now, I am always including these intermediate data sets. With AI, your data provenance needs to expand to include these intermediate data sets that are created and used by your own AI system. That can be the evaluation data sets that you use to test the accuracy of your model. That's one example. It's the embeddings that I talked about before. It's prompt engineering data sets that you use for RAG. And it's staging data sets that you use for things like customizing Code Whisperer. These are just some of the many new intermediate data sets in this new world of generative AI. And if you're going to be your own best auditor, you need to make sure you're storing those new intermediate data sets using the same access and security model you have in place for your data architecture. And you're also logging how those data sets are being used in your generative AI workflows. I can't emphasize enough how critical this is for enterprise-grade generative AI. So one way to think about this is the explainability of data in generative AI. As an example, any prompt response that your generative AI application gives needs to reflect the user permissions to the underlying data. This is super important. The user can only have access to the data that they would be able to see anyway if they weren't using a generative AI application. Now, that fundamental is built into all of our AI services at launch, like Code Whisperer and Amazon Q. But we also incorporate that concept into in-context learning and FM customization. For example, for RAG use cases, you can rely on the existing user-level permissions and fine-grained access control in the embeddings and vector databases like OpenSearch. Today, AWS customers use different AWS services for auditing, like CloudTrail, DataZone, CloudWatch, and OpenSearch, and they govern the use and monitor the usage of their data. You can extend all of those services into your AI system. If you are using AWS managed services for generative AI, you have the capabilities that I talked about. They're already built in. We launched our generative AI capabilities with CloudTrail support because we know in a world where auditing and compliance is just a matter of time, you need to have that audit trail built in. So anytime you create a data source in Amazon Q, it's logged in CloudTrail. You can use a CloudTrail event to list all the API calls made by CodeWhisper. And Amazon Bedrock has over 80 CloudTrail events that you can use for auditing right now to understand how your FMs are being used through Bedrock. For example, if you want to know what actual prompts are used with a foundation model, you can configure Bedrock's model invocation logging, which will record the input and the output of the invoke model call. Using CloudTrail, you can see who invoked the model and when was the model invoked. If you have customized a model with your own data set, Bedrock will log where the data set is stored in S3. And all of this gives you transparency into how you are using what data for what particular training, and it's built in to Bedrock. It's not just the core audit capabilities of Bedrock. You can use other AWS services to get even more layered protection of your sensitive data. I'll give you an example. With Bedrock model invocation logging, you can send your invocation logs to CloudWatch, where you can turn on a capability called sensitive data protection. Now, once you have CloudWatch sensitive data protection, CloudWatch is going to automatically detect and mask over 100 types of sensitive data types over any egress path for your logs. That prevents PII data from being ever accessed by your users through the invocation logs from Bedrock. AWS believes deeply in responsible AI, and you'll see that belief in our services. For example, in order to provide transparency on the model decisions, Bedrock agents show and log the intermediate steps that the model wants to take. That is model decision explainability. That can go into your CloudTrail logs to help you be your own best auditor. In CodeWhisper, the reference log lets you review references to code recommendations that are similar to training data. AWS gives you data transparency in our managed stack because we know how critical auditability is to your enterprise. You also have to think about transparency in responsible AI, and that means explicitly sharing the details and context to use your AI correctly and responsibly. AWS launched AI service cards, and they're a form of responsible AI documentation because they provide customers with a single place to find information about the intended use cases and how to use services that we provide with the best practices and safely. And this week, we've launched 6 new AI service cards, including Amazon Transcribe toxicity detection and many others. Now, as part of responsible AI, as of this week, AWS is also providing intellectual property IP coverage, indemnification coverage for outputs of Amazon Titan models and Amazon CodeWhisper. So if you use one of these generative AI applications or models that I just talked about from AWS, and somebody sues you for IP infringement, AWS will help you defend that lawsuit, which covers any judgment against you or settlement costs. That's responsible AI and the way we work. We're also investing in the automation of adoption of responsible AI. It's one thing to say that you do responsible AI. It's another thing to do it. And it's next level to automate doing it at scale. That's what you get in Bedrock. So for example, guardrails, which was announced in preview this week, it lets you specify topics that you want your generative AI application to avoid and automatically filter out queries and responses in restricted categories. These guardrails work across all FMs, including custom fine-tuned ones and agents for Amazon Bedrock. Another way to automate responsible FI is to build it into your FM selection. Amazon SageMaker Clarify gives you the ability to evaluate and select your FM based on responsible AI definitions. For example, when you're comparing models, and really even models that perform the same function, like summarization, or in the same family, like Falcon's 40 billion versus Falcon's 180 billion parameter models, you'll find that every model performs differently across various dimensions like accuracy, robustness, and toxicity. And now you can use Amazon SageMaker Clarify. You can use it in Bedrock, or you can use it in SageMaker Canvas to evaluate these models based on responsible AI metrics. Your goal is to be your own best auditor, so you are prepared for whatever comes your way for compliance in the future. And AWS is here to help. Whether you're using AI applications like Amazon Q, managed ML AI services like Bedrock, or individual services like CloudTrail across multiple parts of your application. Now, we are just at the start of this journey. I think it's important to note that it's not just about how our models learn about our business context through our data. It's about how we, as individuals and organizations, learn too, about generative AI techniques, about responsible AI, and about how you can navigate the world of taking your data and bringing it to your AI system. Now, at Amazon, we have a leadership principle called Learn and Be Curious. And it says we are never done learning and always seek to improve ourselves. And we're curious about new possibilities and act to explore upon them. And that's what we're all collectively doing with generative AI. And AWS is with you every step of the way. Thank you, everybody. Have a great rest of your day.